Queensland. So there was a small one near Howard, small one Rockhampton, Mackay, Townsville. Most of the major centres through Queensland had their own small power station. But through the mid-70s, the high voltage transmission lines were built and Queensland was connected from north to south. So following that, after Gladstone was built in the mid-70s, the Queensland government at the time were doing deals with Japan for the sale of coal, and with that came the purchase of some good priced power stations from Japan. The first of those were built at Toorong near Kingaroy. They built four generating units there in the mid-80s. Then two more were built at Billawheeler at Kalapa Power Station. And the plan was to build four more in the Rockhampton region. They looked at several places for the siting of this power station. One was down near the mouth of the Fitzroy River at Thompson's Point. So if you just stop on the side, just past this driveway on the left here, you'll be fine. So the whole power station process at the moment, where we cool the water down, which is used to condense steam in the condensers after it's been to the turbine. But I'll recap over all this for you as we go along. Anyway, our water supply comes from the Fitzroy River. When the power station was built in the late 80s, early 90s, an additional weir was built on that water for different parts of the process, and we need to make water up now. I know when you all do your ironing and you have a steam iron, and we all add demineralised water so that the iron, we have a demineralised water treatment plant which is just to the front of us on the left hand side. So the idea of that is just to remove all those salts that are out of the water, so potassium, calcium, sodium, to keep our water nice and clean in a brown colour. Because we put all of that water into our plant, we need to remove a lot of that mud. So there's a plant down to your left. So all of the water that comes on site. So when we make electricity, there's a lot of energy involved in that and a lot of heat that's created. And this little shed on the right hand side, these white bullets, they're full of hydrogen. So we fill the generator full of hydrogen. So the generator is a little round, looks like an electric motor, but instead of the electric motor driving a pump, we've got a turbine spinning the generator, that mud treatment plant that we were talking about before, so that we remove all of our mud from our cooling tower, our water, before we put it into the cooling towers. So straight in front of us, and we'll see it as we sort of turn the corner at the end to the right, is our switch yard. So this is where our generating units are connected into the high voltage transmission network. So we said we've got a transmission network. It's now connected from Cairns, a grey device. It's got some cables connected to it that then ultimately connect up to the large transmission tower. So that's that generator transformer I was just talking about. So it increases the voltage from 20,000 volts to 275,000 volts. So we're adjacent to Unit 4. So Stanwell Power Station has 4 generating units. We can do all of that instantaneously, so we laid a lot of the equipment out here until it was ready to be assembled down in the power station. If we look out the left side of the window, left-hand side, so yes, so then we'll put topsoil back over the top of it and green it, so, or grass it, so yeah, to the left of them. Once we have enough heat inside the boiler, well then we can get the coal started. So to make a fire we need a fuel source, ultimately it's coal. We need oxygen on the highway, and you've seen the coal trains that are going towards the port. Each one of those coal trains holds about 7,000 tonnes of coal. We would use about 10 of those coal trains a week, so we get about 1.5 trains per day. So we're burning about 70,000 tonnes of coal a week, about 10 of those trains a week. So about 3.5 million tonnes of coal a year. So most of this coal that we can see on this is just been sitting there for a long time. It's what we would call our long-term stockpile. Most of the coal that comes in from the train goes through a conveyor belt underneath that large silver roof shed that you can see, drops straight down, and then there's conveyor belts underneath that, pulls the coal out and takes it off to the boiler to get burnt. This coal stockpile that you can see here is really only just sitting there such that if there's an emergency, as rain, the rain will fall on this coal stockpile and it runs down into some small catchment dams on our left-hand side. So any of the coal that gets carried with the water as it rains, we catch that on. So we've got this big hot fire. The gas is used to heat the water up and evaporate it and turn it into steam. We then need to bring that hot gas out, and before we put it up the chimney and out to the atmosphere, we pass it through these equipment on the right hand side with the silver triangles upside down. They're called precipitators. So inside there's a series of plates and a series of little wires, and as the gas flows past with the dust particles from the ash from the coal that didn't burn, we have a high voltage applied inside. That ionizes the dust particles, so it creates an electric charge on the dust particle, and the plates inside have got the opposite electric charge. So as the dust particles are going through, we put a charge on them, negative charge, they get attracted to the plates which have got a positive charge on them, and the dust particles attach to the plates at some, but the economics aren't there to make that work for us at the moment. Oh. I can understand why you do that.
When I was younger, we lived in
then trace elements, giving it colour. And then rose quartz, I'm not sure what one is called, rose quartz. My wife Roy, and we've been operating this business here for 45 years, but it was started not by us but our father, and so we're carrying it on. And then I have some people here very kindly volunteering help from South Australia. This is Ron, who's just sitting over here behind us. His wife Manel's out the back there. And so we cater to people who come fossicking here. And so in case you don't know what we do, we find thunder eggs which are volcanically formed stones. And we also find the lava that forms those thunderegs in the ground beneath us here. I'll try and, there's a lot of you, we can go in a single file line through the buildings.
And that's all we do. Might sound simple, but it gets laborious after a while. But you get there. As I said, there's 3 stages. There's a sanding disc.
I saw a thing on TV where in Iceland there's been a volcano and a runoff. So a year or 2 years earlier, they dug a foot down and it was still red hot. So the insulation in the ground is quite low. So it does make it look again.
Thank you. Now, down driver, Beth Elkins, can you put your hand up please, because this is your meals coming out. Roy Guthrie, Gwen Guthrie, Diane Jones, Beth Lockyer. So if you just keep your hands up, and then Joe can bring your meals in. So yours is
Varieties of boa and mango. Some people get confused that they're different, they're not. The other variety we grow is an R2E2, they're the larger variety. We do mainly a lot of export for those. The Chinese and the Asians love them. The bigger the mango, the better for those guys.
Well, some of us went to CQ University Research Station.
Yeah.
And there's apparently a grower of mangoes down at the coast who's using not just the cameras but also a robotic picker.
Yeah.
You haven't investigated
So the
that?
CQ Uni have actually been doing a lot of work with the mango and avocado industry and have spent a fair bit of time out here. But yeah, the mangoes get graded here. So there's lots of arms moving very quickly. Once the pallet's full, it gets stacked up. I think we put 128 to a pallet. It gets strapped, marked, and then into the cold room. Mango, we've got plenty more. Anyone miss out?